Hey guys, today we are gonna learn what is stereoscopic vision and how we can use this to reconstruct a 3D scene. So basically, what normally camera systems are single camera system. In single camera system, which is also called a pinhole camera, what it captures is a projection of original 3D scene. So some valuable information like depth is lost in the projection during the projection. So when we finally get the image, it doesn't have any information regarding the depth. So it is a two-dimensional image. Only x and y axis we get, but the depth axis, which is z, it is completely lost. For example, if two objects are kept in an image, you can't detect which is far or which is near. You can, if some information like shadows and other things are given, what basically is your brain interferes. Brain makes a perception about that image. It doesn't hold any actual depth information. So you can see a bigger object which is far from a camera may look similar to a smaller object which is near to camera. So you can't decide which object is near. You don't know anything about the depth. For depth, you need an additional dimension which is lost in the projection. So only way to get the information about depth is actually get that attribute in an image or some. What stereo vision does, it have two cameras and the displacement between those cameras is known to us. So those two cameras captures two images. Then uh, uh, we do some calculation on those two images to get the value of depth. So a new dimension z, actually not new, but it is regenerated. The depth can be calculated. So stereo vision is used in application where depth is required, like 3D cinematography, robotic vision, and human eye is a great example of stereo vision. You can actually see this if you close one eye and look, and then close the other eye and look from the first eye. You will see that the object you are looking will get displaced. So each eye has its own image, which then brain it transform and makes a perception about the scene. You can see like there are two cameras and here is an object. So for each camera, different image is formed, and then a system merge those images and forms a 3D scene. So main part is depth calculation from stereo images. So we can see in the image, then there are two images from two different camera lenses. So how this point is calculated? This point is nothing but the intersection of this image plane, and the ray from the original point in the original 3D scene and the camera. So this ray intersects in this point, same for the image 1. So the point in the image is calculated by from the intersection of the ray and the image plane. We can revert the operation. If we know the point in the image plane and the location of the camera lens, we can draw the ray, and so one ray from one image. So we have two images, so we will get two ray, and if we get the point of intersection of those two rays, we will get the point in 3D space. So we have to just apply the math to calculate these values x, y, and z. You can see in the image, uh, like z by f will be equal to xl upon z upon xl. So you can see here z upon f will be equal to x upon xl. So same, and this is for the left camera. If we look for the right camera, x minus b, this upon xr will be equal to z upon f. So same for the y-axis. Basically, the camera is displaced in the x direction. We are making it because we are making the origin as a left camera. So there will be no displacement in the y direction. So it will be same for both the left and right. So if we solve these equation, we will get our point x, y, z. So the equation can be generalized, so we will get the equation like z equal f into b upon xl minus xr, and x can be further calculated by xl into z by f and y equal yl into z by f. What is disparity? Disparity is the displacement of two images, like the same object in the left image and the same object in the right image will be some displaced, will be displaced by some value. So if you look at this formula, z equal f into b upon xr minus xr, if z is low, which means the point is closer to the camera. If z is low, then xl minus xr should be high. So the difference between those left image and right image will be high, which means the disparity will be high. So you can look at the other way, like if the disparity is high, it means the point is closer to the camera. If the disparity is low, the point will be far from the camera. So we can judge the depth by looking the disparity. You can't judge this in the single camera system because you don't have such attribute. But in a stereo image, you can judge the depth by seeing the disparity. You can see like this image is have more disparity by this image. You can see in the perspective view, which is a single camera system. You can see this image is closer to us or far from the perspective, far from the origin. So you can see that this image which have low disparity is closer to the origin uh, than this image which has high disparity. So stereoscopic vision can be used to regenerate the original 3D scene, as it can regenerate the depth value. It can plot our scene into a XYZ three-dimension system, but as we know that each image has its own regulations, is that it has its own resolution and it is pixelated. So if we regenerate the 3D scene, there may be some error in the depth. So it can regenerate the whole 3D scene, but it will not be as accurate as the original 3D scene was, because at first the dimension is reduced from a 3D 2D projection for the both left and right side of the camera. So stereoscopic vision is useful for creating a 3D scene, but it's not that good for regenerating the 3D if its resolution is low. Thank you for watching.